no, I'm sorry. We're going to sketch these. This was just on your parametrics test, right? So can everybody sketch these? Okay, are we watching? So we're gonna go to what we're gonna first turn the calculator on. We're gonna go to mode. We're gonna put in parametrics. We're gonna leave it in degrees. Your window, because you're in degrees and you're either making a circle, an ellipse, or something, has to go from 0. T is your angle right now to 360 degrees. Make it go like, say, every 15 degrees. And then the rest can go from -10 to +10. Just a regular screen. Your normal screen goes -10 to +10. Okay, so now you're going to go to your parametrics and you're going to put these guys in. Just put in a regular T. You don't need a 2T in this. And 2 sine T. Now, when you graph this, you need to pay attention to your orientation. So try to catch where it starts. Guys, watch. See where it started right here? What did this make? An ellipse. Can you almost see it? It's over 4, it's up 2. It started right here. This is what I need to tell on this. You need to be able to tell me where it starts and then it goes like this. You need to put the arrows there. So start here and put the arrows there. And then you're going to do the same for the other one. Okay? Just make sure I see where does it start and where the arrows go. Question on that? Heather? Okay, do you have your calculator right now? Okay, let's take a look at your calculator. What does your window look like? What's your T? Your T has to go 0 to 360, otherwise it's going to stop. Because aren't we going full circle, technically, when we make an ellipse all the way around? And the hyperbola 2 is going to make us go all the way around, a circle, whatever. So we've got to go 0 to 360 on that. The application is where it goes 0 to, say, 10 seconds or 0 to 5 seconds. And then you should probably be okay. If I cut my step too short, watch what happens. It doesn't go all the way around. It says, whoops, stop at angle 300. Can't go any further. Okay, so the other one should be okay then. These, did I give you the formula? On your formula page for this?
Did, but I don't remember when you're supposed to use which one. I think you're supposed to use PERT for these, right?
PERT is continuously.
So those things that A over P, all of something.
Continuously is only PERT. It should be in your review sheet. Now, annually, N is how many times you compound interest. So annually is once a year, 1. N is 1. So technically it kind of gets rid of your fraction. So you just look like this, basically. Oh, to the tip. That looks like this. It looks like that. So if you want to take a shortcut, you can do that. Key to this is identify this. This is what you invested. This is your rate. How do I put this to a decimal? 0.725. And this is your time. So all you got to do now is just plug this in. 5,000 times 1 plus 0.0725. Don't even resolve this. Just put it in your calculator just like you read it. Leave the plus there. You don't have to take away the plus. You can just put it in your calculator just like that. And money, I should round to how many positions? 2. So we should get 8752.83, or no, Okay? The more you compound, the higher this should go. If you compound quarterly, what's n? 4. So all I have to do now is put n in here and n up here. So I invest my 5,000. I'm increasing my rate. What the 1 does, it rolls your interest in over and over again. If you just put the rate, you will only get the interest made for that 1 year. So keep that in there. So now it's 0.0725 divided by 4 to the 4 times 8. When you put in 4 times 8, this one comes out to be $8,883.93. Monthly is what? What's n? 12. So we're doing the same formula again. Just putting a 12 in my n. Don't forget to put the 12 up here. 12 times 8. You should see steady increases. Not major, but steady. This one will be 8. Something happened in my printing this out and they came all weird. Point what?
891. Wait, 88. Wait, I got 8,914.62.
So were these all off?
No, the first one's right.
You got 8,000. What'd you get on this one?
8,914.62.
You sure?
Wait, which one?
You got that one too? Okay, because these are, I can't read these numbers. Like something's wrong with the difference between my Microsoft and their Microsoft. So how do I say daily?
365.
365. So you're going to do the same thing here, but now just put 365. Don't forget to raise it to the 365 times 8. And you're going to have to tell me what you got for this one too.
8,929.68.
Thank you. And continuously, this is where you use your perk. Perk says principal 5,000 base E to the rate 0.0725 times 8. And this one is 8. What'd you get for this one? 898.
8,930.19.
Thank you. I don't know why these came out so weird. Okay. Remember, money automatically rounds to 2 nice decimal points. You're going to see one of these problems definitely. All right? So let's move on.
12 times 2 is 12 times
What's that, hon?
8. A monthly, that's 12.
12 times 8, because 8 is your time. 8 is still 8 years. Time is still 8 years. Okay, if 8,000 is deposited in a bank at a rate of 6.2062, compounded quarterly, how much will be in the account after 20 years? Same situation. So you're going to take $8,000, put it in at a rate, just watch those decimals on that rate, compounded quarterly to the 4 times 20. And I think it's $27,383 to the nearest dollar. So if you could leave it in there for 20 years, and if we ever got a rate of 6.2%, you'd make a lot of money. If, but I doubt that will ever happen. Okay. Bacteria. Now, can we just go over your basic formula? Remember your basic formula? This is your initial value. This is your rate. This is your time. And sometimes your time has every 3 days. It has a series to it. If I'm doubling, if I'm going to double, then my rate, my B is 2. If I'm going to half, then what is my B equal to? Half. If I'm going to only increase by 5%, I got to make my B be 1 plus 0.05. If I'm going to decrease by 5%, then I'm going to make my B be 1 minus 0.05. A is your initial amount, whatever you start with. All of your, and notice all your interest formulas work the same way. This is my P, this is my rate, there's my 1 plus 0.05, there was my thing. We just had a difference of time and compounding factored into there. So if you have bacteria, and initially you have 6,000, and you grow at a rate of 10.2 per hour, so you're working this by hours. Okay, so just be careful of this guy. Well, is this a continuously?
Yeah.
Okay. So continuously again, continuously is, I'm sorry, I went through this whole big speech for this, but continuously is always per. But just remember, you'll need this guy for the rest of it. So 6,000, base E, flip this to a decimal, and then my time. I don't know my time, and this has to end up being 32,300. Now, if my exponent is my variable, what is the only thing that can bring that exponent down? Is a log, and in this case a natural log because it's base E. So we could cheat a little bit. This only belongs to this. So we can divide both of these by 6,000. If they divide evenly, life is good. If they don't divide evenly, leave it as a fraction. It does reduce to this. Now, you have a power rule. Whenever you have an exponent, that's a variable. So because this is base E, take the natural log of this side and the natural log of this side. Now this guy comes down here. What happens to ln and E? It cancels out. And then we have ln. You can leave this just like this. And divide this by whatever's in front of the T. Be careful when you put this in your calculator. You're putting in ln parentheses. I think it gives you a parentheses. You're putting this in, and then you divide, close your parentheses, and divide by 0.102.
When I did this the other day, I got some crazy.
You got a crazy number? Is this 16? But did you get this?
I got to it, but when I divided it,
Okay, so it probably happened in your calculator. Let's just take a look at your calculator. So ln is here. It gives you a parenthesis, so you're going to say 323 divided by 60. Don't forget to close that parenthesis. Then you're going to divide by 0.102. And it should give you 16.5. Now, but, that's per hour. So 16.5 hours to the nearest minute is 16 hours, 30 minutes. Because 0.5 of an hour is 30 minutes.
how did you know it was hours?
Because it was here per hour.
Oh. Because when I put it back in, then I didn't get the number. And I was...
Yeah. Okay, so finish these up, guys. What we'll do is, we'll finish.